is day 17 in geometry, and it is Tuesday, not August anymore. Now it's September, Tuesday, September 2nd. We did not have school yesterday, Monday, so nobody missed anything yesterday. Last week, though, on Thursday, we did start a new unit, Unit 3, because we finished our triangles unit. And in this unit, we are talking about polygons, quadrilaterals specifically, though, so four-sided shapes. And we focused a lot on interior angles of parallelograms. So in all of these parallelograms, I've given you one angle, and based on what we learned last week, we should be able to find every other missing angle just from that one angle. So for number one, I'll walk us through that one, and then I'll have you guys help me with the rest. So one thing that we know about parallelograms, this is a fact, is that the interior angles our opposite angles are equal to each other. So I could go ahead and mark that these two angles, the 60-degree angle and angle Z, are equal. The other pairs, X and Y, are also opposite, so they will be equal to each other as well. Now, I'm going to go ahead and write down here X, angle Y, and angle Z. So without doing any math, is there one angle that I already know? Z, it's equal to 60. Those are opposite angles. So angle Z is 60 degrees. How would I find angle X and Y?
Here equals 360.
Ooh, yes. I know that the sum of my interior angles, all four of these, will add up to 360 degrees. So I could set up an equation using the 360. There's another fact that we learned last week as well, though, about my two angles that are right beside each other. Angles that are right beside each other add up to 180 degrees because that's half of 360. That's half of the angles. And a good way that I like to show this, I'm going to show it again, is if I have my angle X right here. Oops. Sharpie is going to run out of ink. Okay, well, angle X is right next to angle Z, and you can tell they make a 180-degree angle because they form that straight line. You can do this with angle X and the 60-degree angle as well. I just got to turn it a different way. They create, let's get that glare. Come on. They create a 180-degree angle, a straight line. I know that is hard to see, but we see it there. So the fastest way to solve for angles X and Y would be to solve for one of them because they're equal to each other. If I know one, I know both. And the equation I would write is that, let's do X. I could say X plus 60 equals 180. And then how would I solve for X? Subtract 60. Okay, and then we would get X equals 120, I believe. So now I know that angle X is 120 degrees. And if I know angle X is 120 degrees, so is Y. Those are equal. Good. Perfect. Perfect, perfect. So we're just going to do the exact same thing for the rest of them. Number 2, I know that I have one angle that is 83 degrees. Which of these angles is equal to that? C. So I already know angle C is 83 degrees because it's an opposite angle. And then what could I do to solve for A and B?
A plus 83.
Perfect. A plus 83 equals, these two add up to 180.
Oh, 180.
Okay, I think that's what you meant. Now, if we were going to do all 4 of them together, it would be 360. But when we're just doing 2, it'll be half of that 360, 180. So then we'll subtract 83. And we get A equals, let's see, that be 97?
Yep.
97. Okay, so if angle A is 97, so is angle B. Good. Good, good, good. It's not too difficult, I hope. Let's look at number 3. I have an angle that is 112 degrees. Which angle, Q, R, or S, is equal to 112 degrees? Angle is the opposite of 112. R. Good. It's right across. So I can go ahead and fill out angle R is 112 degrees. And we're going to just do the exact same thing as we did in the first few to solve for Q and S. I know that they are equal to each other. S and R would add up to 180. Q and 112 add up to 180. You could also do 112 and S. There's so many ways to do it. So how about we set up, I'll solve for Q. Q plus 112 equals 180. I'll just subtract the 112. And we'll get Q equals, let's see, I got 68. Can anybody confirm that? Perfect. 68. So if Q is 68 degrees, what else is 68? S. Good. Just one left. This time we're solving for angles T, angle U, and angle V. Which angle do we already know? Angle V. These are opposite, so they are equal. Angle V is 27 degrees. And it's the exact same process, right? We'll just add angle T or angle U with number 27 and set it equal to 180. Let's see, T plus 27 equals 180. We'll subtract that 27 and get T equals, let's see, I got 153. Will anybody confirm that? Okay, good, good. So angle T is 153. And of course, angle U is equal to that because they're opposite. Okay, so that's what we did on Thursday. The only thing that we did that was slightly more advanced on Thursday is we used this property where we can add those angles together and set them equal to 180 to solve. The only thing that made it slightly more complex is instead of just regular numbers, there would be some variables too. For example, like in number 1 here, we had 8x plus 3 and 105. Since they're right next to each other, we would add them together, set them equal to 180. Now, before we do move on to a new sort of set of notes today, be totally honest with me. Does anybody want to see an example of this type of problem worked out before we move forward? I know not everybody was here Thursday. Okay, we want to see one? All right, so if you have already done this, basically if you were here Thursday, this will just be a review for you. But everybody else, first, let me see. I had a worksheet so that you can do some practice. If you need this worksheet, I don't know if I put them in your folders or not. If you need this worksheet, raise your hand and I'll bring them to you. Okay, I know you do. You do. Perfect. I'll pause this and bring them to you. Okay, so everybody should have that worksheet. So we'll just look at 2 different examples from that worksheet. This was the day 16 practice, and I will find problems that we didn't work out together. Let's see. Oh, some of these would work. Okay, let's flip to the 4th page of this worksheet, and let's start by looking at number 13. And I've already got the answer here, so we'll know if we get it correct or not. But we're going to look at 2 specific examples, number 13 and number 15. And you'll see when we do these why we're going to look at these 2 specifically. And this would be a good thing to write on this worksheet to help you remember. So number 13 here, I have 2 angle measures given to me. I have angle V, which is 136 degrees. And I know that that's going to be equal to angle T because they're opposite. The other angle that I'm given is U. So let me grab another color. And opposite of U would be S. Yes, yes, that's the word. So there were 2 different relationships that we could have. We could either be given 2 angles that are right across from each other, and they would be equal. Opposite angles are equal. Or, like in number 13, we have angles that are right beside each other. These are consecutive angles. So a note to write here would be consecutive angles up to 180 degrees. Consecutive meaning right next to each other. And I could say, because these are consecutive angles, V plus U equals 180. Now in this problem, we're going to be solving for X. What equation could I write using this idea, V plus U equals 180, but utilizing the values they give us in the problem? What would I write?
136
plus
21x plus 2 equals 1.
Good. 136 plus 21x plus 2 equals 180. And all we're doing here is plugging in the values they give us. And from here, we just follow the same process we do when we solve equations. We'll look for like terms, anything we can combine. And I can see here I can combine my 136 and my 2. And what do I get when I combine those? 138. Then I bring everything down. Plus 21x equals 180. My next step would be to get rid of anything that is not x. I'm going to subtract that 138 from both sides to get rid of it. Bring down 21x equals, let's see, 180 minus 138 is 42. And then we just have one last step. We'll divide by 21 to get x by itself. And we should get x equals 2, which we did. There you go. So number 13 is a problem with consecutive angles, angles that are right next to each other. When we have consecutive angles, we will add them together, set them equal to 180. Now there is one other case. And before I move on to number 15, does anybody need to see this still? I see a few people still writing. Okay, take your time. I'll pause this for just a minute and let everybody get caught up. Okay, so now we'll look at number 15. This is the other case that we will see with parallelograms. Number 15, these are not consecutive angles. This time we have opposite angles, and opposite angles are equal to each other. So I'm going to write here, opposite angles are equal to each other. So I've got angle R and angle T, and I know because these are opposite, angle R is equal to angle T. So with this information, what equation could I write given the values in this problem? Yep, we're just going to plug those in. 6x minus 8 is R, and T is 40. We're just setting them equal to each other. Once you have that equation set up, all you have to do is solve it. So I've already got 6x minus 8 equals 40. I'm going to get rid of everything that's not x, so minus 8 has to go. We will add 8 to get rid of it. Bring down 6x. Bring down equals. 40 plus 8 is 48. And then we just have that last step. We'll divide by 6. And we should get x equals 8. And 48 divided by 6 is 8. So we did it right. Okay. So there's your little review. And before we do move on to kind of the next thing today, do we have questions about either of those? Those are the only two scenarios that you'll see with interior angles in parallelograms. Okay, I will leave that up for a moment and let everyone finish copying it down. And then if you finish, go ahead and get your notes out. We are going to start a page of notes. We're going to be drawing a diagram for our notes. So I'm going to pause this. All right, so I'm putting this to the side and I'm going to start a new page. So I will title this as Geometry 3. And we are going to be classifying quadrilaterals today. Let me mark this as page 1. These are our day 17 notes. And again, it's Tuesday, September 2nd. Okay, so let me pull up this little chart. I'm going to be copying. So we are going to start with a great big 4-sided shape that will take up most of your page. I am going to write the word first that says quadrilaterals. Under that, in parentheses, I will just write 4 sides and 4 angles. Okay, and then I'm going to take my ruler and I am going to draw a big old box around that. Now, inside of this, and I'll give you guys a minute, inside of this, the next most specific type of quadrilateral is what we've been talking about, a parallelogram. So a parallelogram is a quadrilateral. It's got 4 sides and it's got 4 angles, but now it must also have 2 sets of sides that are parallel, and we will write that down here too. So I'm going to write below this parallelograms. Parallelograms. And what I'm going to do for this section of this little chart is I'm going to draw a sort of parallelogram shape inside of this big quadrilateral. So I'm going to start with a line that goes about 4.5 inches. And whatever length you choose for this first line, you're going to use the same length near the bottom, but shift it over a little bit so that you have a tilted, you'll see what I mean, hang on. So I'm going to do 4.5 again. And then whenever I connect those sides that I just drew, I'll have a giant parallelogram inside of my quadrilateral. So parallelograms must have 2 pairs of parallel sides. And we can mark that sides are parallel using those little arrows on the sides. So I'll put an arrow here and another arrow. And since this side is parallel to the opposite side here, I'm going to draw the same number of arrows over here as well. So there's my one pair of parallel sides. And then I'll put one arrow on the other pair like that. Now, we're going to fit two more little categories inside of the parallelograms. The next kind of section we're going to do is the rectangle. So I'm going to leave a little space here, leave some space in the middle, and we're going to draw a rectangle down here. So I am going to use a different color now. Let's do orange. Okay, so a rectangle is going to have the same things as a parallelogram. It's going to have two pairs of parallel sides, but now it's also going to have four 90-degree angles. So do your best to make it look like it's got 90-degree angles. I'm going to write here rectangles. A little space. I'm going to write under that must have four 90-degree angles, four right angles. Bless you. Okay. And so I will mark some right angles on my rectangle with my squares. And then above it, we've got one more category. Now this category is going to actually overlap with the rectangle a little bit. I'm going to start with, let's see, we're going to need four sides that are the same length because the next category is a rhombus. So I am going to, let's do, make it fit. I probably should have wrote that a little bit different, but that's okay. Let's do 2 inches. And I'm going to start with a line here. It's 2 inches. And then this is kind of hard to draw, but we're going to do our best. I gotta make 2 inches fit in here somehow. I didn't plan this out very well. do 2 inches here. Well, dang it, this is supposed to just overlap with the rectangle. Okay, we'll get the idea. 2 inches. I'm sorry, I know, it's kind of making me mad too. This is a rhombus. It has 4 sides and 4 angles, so it is a quadrilateral. It has 2 pairs of parallel sides, so it's a parallelogram. And there's going to be something that goes in here. So this is a rhombus. And it's got 4 equal sides. And the very last thing that goes inside of this little overlap is a square because it's got 4 90-degree angles, 4 equal sides, 2 pairs of parallel sides, 4 sides, and 4 angles. So square is the most specific quadrilateral that we can have. Yeah, this is making me mad how I drew this. I may have to remake this and just make copies for y'all because this isn't very intuitive. I laid it out wrong. I apologize. I hope we get kind of the main idea of this though. Basically, quadrilateral is the most general category. It can mean any shape as long as it has 4 sides and 4 angles. Nothing else matters on it. The next most specific thing we can have is a parallelogram. So that's a quadrilateral that has 2 pairs of parallel sides. Now, a rectangle and a rhombus also have the 2 pairs of parallel sides like a parallelogram, but they get even more specific. A rectangle also has to have 4 90-degree angles. A rhombus doesn't have to have the 90-degree angles, but it does need 4 equal side lengths. Now, if you have 4 equal side lengths and 4 90-degree angles, then you have a square. So, again, I didn't do a wonderful job drawing this, but we get the idea, I hope. We get the idea. So we can use these facts to help us categorize shapes based on their side lengths, based on their angles, based on if the sides are parallel or not. And we can move forward from there. So let me pull up a few problems that we can kind of practice. Let's see. I'll leave that up while you guys finish copying that. Does anybody still need to see this? See a few people still drawing. Okay, let me pause it and I'll give you guys a minute before we look at some examples. So everybody should have this worksheet now, and we're going to use that little chart we just drew to decide what the most specific name for each of the shapes is. Now, technically, I could go through and say every single item on this page is a quadrilateral. That is correct. They all have 4 sides and 4 angles, but we want the most specific name. So we need to think about what features it has and how specific we can go. So for number 1, what we're going to do is we can kind of look and see what do they specify. So for example, I see because of these arrows. What does this picture tell me about this shape? What do these arrows mean? What'd you say? It's a parallelogram. How do you know that it's a parallelogram?
Two pairs of parallelogram.
Yes, exactly. So, two pairs of, this means parallel, of parallel sides. So, this would be a parallelogram. Good. Now, number 2. I see my opposite sides are equal to each other. I see I have 4 90-degree angles. What's the most specific name I could give this shape for number 2? Well, a square needs to have 4 equal sides. This one's just got 2 sets of equal sides. Rectangle. Yes, yes. If these all had 1 tick mark, it would be a square. But since we don't know that all 4 sides are the same, this is just a rectangle. 4 90-degree angles. And then 2 pairs of equal sides. That's a rectangle. What about number 3? That's a square. How do you know it's a square? 4 equal sides and all 90-degree angles. So that is a square. Good. What about number 4? A smaller square. It's got the same features as number 3, so that would be a square. Okay. Now, what about, we'll skip 5 and 6 for a minute because we've already done a few like that. What about number 7? What do you think for number 7?
It looks like a really messed up parallelogram.
Well, let's see. For it to be a parallelogram, we need 2 sets of parallel sides.
Why is that messed up?
Really messed up. So I guess it wouldn't be a parallelogram, would it? What's the most specific thing we can call this shape? Go ahead.
Quadrilateral.
A quadrilateral. I know it's got 4 sides and 4 angles, but that's all I know. I don't know anything else. This would just be a quadrilateral. That's the most specific we can get. Okay. What about number 9? Rhombus. How do you know? 4 equal sides. Good. So that would be a rhombus. Okay, so we just did 6 of these together. I gave you 20 problems. It shouldn't take too long to identify what each of these are. So what I would like for you to do now is I would like for you to name every single shape on this worksheet. Try to finish all of them. And I'm going to say in about 5 minutes or so, we will look at these together and then I'll give you a break. So I'm going to pause this for a minute and let you guys work on that. So I've had most of you come and show me your papers now. So I'm just going to go ahead and start giving these answers. If you're not done yet, keep working. But this way you can check and see what you got right or wrong when you do finish. So number 5, is a rectangle. Number 6 is a parallelogram. Number 7, we said quadrilateral. Number 8, rectangle. Number 9, we said was a rhombus. 10, quadrilateral. Number 11 is a square. Number 12 is a rhombus. Number 13, parallelogram. Number 14 is a square. And I'm going to flip to the back. Number 15, quadrilateral. Number 16, square again. 17, square. 18, parallelogram. 19, quadrilateral. And same with 20. Okay, so those are all of our answers for classifying different types of quadrilaterals. And it is 10:11. So let's go ahead and take a little break, and we will be back. Let's see. Let's say absolute latest 10:26. That's 15 minutes. So if you need to get up, stretch your legs, bathroom, drink, whatever you got to do, feel free to do that now, and we will be back in 15 minutes. All right, we are back from our break, and we are going to write a few more notes. So I'm going to start by just titling my page, Geometry. And this is 2 for me. 17 notes continued. Okay, so we have just talked about how we can classify different quadrilaterals, different shapes that have 4 sides and 4 angles. And now we're going to kind of switch gears and talk in a more general sense about shapes, not specifically 4 sides and 4 angles. We're going to go back to polygons, but this time, not just any polygon that has any number of sides, any number of angles, and doesn't matter what those lengths are as long as they connect. We're going to talk specifically about regular polygons and what that means. And remember, a polygon is just a fancy name for a shape that has straight sides and angles, and it's closed. It can't be open. It'll have an actual closed space. What makes a regular polygon is that all sides are the same length and all angles are the same measure. So all sides and angles are equal, all of them. And we can talk about a few different types of regular polygons. Of course, we start with the smallest amount of sides you can have is 3. Because if you only have 2 sides, I mean, that's a line. You can't really, or it could be an angle. You got to have at least 3 sides to be a polygon, to be a shape. So we could start with a 3-sided. All sides are the same, all angles. That would be our classic triangle. Next, we have a 4-sided shape. What would a 4-sided regular polygon be called? Square. Good. That would be a square. Is there such thing as a regular rectangle?
Yes.
Hmm.
No, no.
Nope. Because a regular rectangle is just a square. If they're all the same side length, it's a square. So from here, we get higher and higher with the number of sides, and you can actually go up very large in number of sides. And this is where it gets trickier to draw the shapes. So don't worry if your shapes are not perfect. Next, we're going to have 5 sides. 1, 2, 3, 4, 5. I'll do my best to make them look equal. Yeah, it looks like a house. Does anybody know what a 5-sided polygon is called? A pentagon. Good. Penta is that prefix that means 5. Pentagon. Okay, next, we have 6 sides. So I'll do 1, 2 here, 3, 4, 5, 6. That's definitely not drawn to scale, but we'll pretend it is. A little bit, it does. Does anybody know what a 6-sided polygon is called? A hexagon. Good. I'm gonna write in here 3, 4 sides, 5 sides, 6 sides. We could keep going. Now, as far as pictures go, I'm not going to expect you to draw past the 6 sides because I don't know how well I can do that either. But we are going to write 7, 8, 9, 10. And we're going to talk about what those are called. 7 sides, 8 sides, 9 sides, and 10 sides. Does anyone know what a 7-sided polygon would be called? Heptagon. Normally we don't know past hexagon. I'm impressed. Heptagon is 7 sides. So Heptagon. 7 sides is called a heptagon. I bet we know 8 sides. Octagon. That's okay. 8 sides is an octagon. Octagon, that's the shape that a stop sign is. Does anyone know past octagon? Anyone know 9 sides? You know it, Dustin? Can't remember it. It is called. Ooh, wait, did you say that again? Nonagon. Yep, that's right. Nonagon. 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 For 9 sides. Does anyone know 10 sides? Pretty close. Pretty close. Not tenagon. This is called decagon, like decade for 10 years. Decagon. Okay. Can't remember 11 off the top of my head.
There's 11.
There is 11. We can name even further if we really wanted to. Ooh, okay, I see it. I got it. This one was new to me. So if we wanted to go further, let's see, 11 sides, 12 sides. We'll go just to 12 for now. 11 would be called a hendecagon. I don't know why. Hendecagon. I'm sure there's some reason for that. It's Hendecagon. Hendecagon is 11 sides. And 12 sides is dodecagon. 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 Now, as we get into larger numbers, 13, up into however many more. Infinite? I don't know. What's nice is after a certain point, I think our mathematicians decided this is a lot of names to remember. So, one other way that we name polygons by their side lengths is whatever the number of sides is in. So I'm going to write number of sides gone. So if it has 28 sides, it's a 28-gon. Very creative.
After dodecagon, they realized this is such a dumb idea. Decided to push the numbers.
Yeah, they're like, this is a lot. Let's do something different. So if I wanted to know what like I said, 28-sided shape is, it's a 28-gon. That's the name of it. Now, I'm sure there's more specific names, but we won't go past 12 in here just for the sake of simplicity and not running out of room on our paper. But these are just some examples of names of regular polygons. So I'm going to label this little section here as names of regular polygons. And then we're going to use these names and learn some actual mathematical formulas. We've been doing a lot of classifying today, but now we'll do some math. Okay, polygon names. So in a regular polygon, in any of these shapes where all of the sides are the same length, all of the angles are the same size, we have some formulas we can use to find different things about these polygons. And these formulas get used frequently if you are, for example, a builder, you're building things. Maybe if you're a gardener and you're trying to figure out how much material you need or how much seed or how much soil. So here's what we're going to talk about next. Let's talk about perimeter. Perimeter.
Does everything add up?
Say it one more time.
Everything added up together.
Everything added up together. What do you mean by everything?
I don't know. I swear I remember perimeter. And
Like sides, angles?
I think sides.
Sides, yes. The perimeter is all of your side lengths added together. So it's the distance or the length around the outside of the shape. That's your perimeter. Like the fence. If your shape was the yard, the backyard, your perimeter is the fence that goes around it. The Make sure I give you the right formula. It's been a minute since I did this.
It's amazing what I remember from fifth grade.
Right. Right. Okay. So a simple formula for perimeter. Remember, N means number of sides. And we're going to say, well, here, let's relabel that. N equals number of sides. And S is going to equal the side length. So the formula for finding perimeter is just, now this is for regular polygons only. This won't work for every shape, just whenever all the sides are the same. We're going to have N times S. However many sides there are times that length. And that's going to give you the perimeter. So perimeter equals N times S. Like that formula in my notes. And then, for example, let's say I have an octagon with a side length of 25 inches. How would I find the perimeter of this? Of an octagon with a side length of 25 inches, a regular octagon. 8 times 25 is as simple as that. Octagon, I know that my side length is 25. My number of sides is 8. So, N times S, 8 times 25.
200 exact.
200 exact. So our perimeter, remember, we're just measuring a length. This is not a space being taken up. It's just the length. So we're just going to use that same measure of inches here, 200 inches. That is one example. Not too bad. The next thing we'll talk about, though, is area. And this is where it can get a little bit tricky just because we have to learn one new word. Yes, the area is the inside. It's basically the space that that shape will take up. And I'm going to write over here for perimeter. Distance round outside of shape. And then area is the space inside of the shape. We'll have an area formula. Now, we are going to introduce one more letter, and it's going to be a lowercase a. The lowercase a is called the apothem. And I'll show you what that means here in a minute. Apothem. To find the area, we can take the perimeter times the apothem and divide by 2. Now that's going to sound like nonsense until I show you what the apothem is. But for a regular polygon, before you can find area, you need to have your perimeter. So that's why I'm showing it to you in this specific order. Going to make solving these types of problems much easier if you try to do it perimeter first and then use that to find area. Just going to highlight these in S and A so we don't lose track of them. So these two formulas, very important. Make sure you've got these written down. And then I'm going to show you some examples of area on the next page. But I'll wait, I'll let everybody write that down. Example on next page. Okay. Now, something I always recommend that you guys do when you're using formulas, and I'm going to do it right here with you, is I like to write that formula on a sticky note so that I can move it around with me to the next page and to the next problem. You don't have to flip back and forth as much. So if you all want to do that as well, there should be sticky notes at each of your tables. I am just going to do that before we go to the next page. So let's see. I am going to write my little key at the top that n is number of sides. Length. And my little a is apothem. E equals n times s. And a equals e as in perimeter times little a apothem divided by 2. So on to the next page. I'm going to write that this is page 3. Day 17, notes continued. And for example, let's say we have a pentagon. I'm going to do my best to draw a pentagon. And in this example here, we're going to talk about what apothem is. So make sure you draw this example. All my angles are equal. All my sides are equal. And what we'll do after we draw this shape is we will put a dot as close to right in the middle as you can. And then we are going to draw kind of a dotted line going down from the middle to the side. Don't draw this line into an angle. Draw it to the middle of a side. And it should be touching the side at a 90-degree angle, like this. Should be perpendicular to the side. This length here is the apothem. So whenever you're solving problems like this, the apothem will be given to you. It might not be labeled as the apothem. You'll just need to recognize that the length that is inside of the shape that goes from the middle to one of the sides is the apothem. So, for example, we will say that one of the side lengths of this pentagon is 4.3 inches. And the apothem is 5.1 inches. And we want to find perimeter and area. So if my perimeter formula says that I need to take the number of sides times the side length, what numbers am I going to use in this formula?
4.3 times 5.
4.3 times 5. Yes. 5 is our number of sides. And S, our side length, is 4.3. So we can just do N times S, 5 times 4.3, or 4.3 times 5. Either way will give you the same answer, 21.5. Good. What would our units be? Inches. Good. 21.5 inches. Okay, so we just found perimeter. I know that there's 5 sides. Side length is given, so we did all that. And then
you take 21.5 times 5.1.
Yeah. So we just did the perimeter. Now with the area, the only new number we need is that apothem, 5.1. So we're using that formula here. Area, I know my perimeter now. Apothem is 5.1 because it's right here. So I will just plug that in. 21.5 times 5.1, and whatever that is, we divide it by 2. Let's see.
109.65.
Yes, perfect. 109.65 divided by 2.
54.825.
54.825. Good. 0.825. Now, this time we're taking a different measurement in terms of our units. We're not measuring a length anymore. We're measuring area. Does anybody know what our units would be here? Instead of inches. It would be
Squared.
Yes, inches squared. Good. Inches squared. So there you go. Your perimeter we found very easily. And then your area, once you have your perimeter, you can find that not too hard either. I'm going to keep this here. Okay, so I'm going to give you all an example to try on your own. And this time I'm not going to draw a picture, I'll just give you the detail. This shape has 11 sides. It has side length of 55.4 inches. And an apothem this is possible, I'm making up numbers, of 304 inches. Find the area and the perimeter. Go ahead and try to use these formulas and solve the area and the perimeter of this example here. I'll go ahead and go over this. Double check your work, make sure you got it. First we'll do perimeter. What would I multiply? Find the perimeter here. Good, 11, that's my number of sides, times 55.4, that's my side length. And what do you get when you multiply those? 609.4. What would my units be? Inches. Good. Not a bad idea to put this over here on your sticky note. I'm going to write inches for perimeter, and I'm going to put inches squared on area, just as a reminder. Okay, so I found my perimeter. How do I find area? Yep, you're just going to take that number we found, the perimeter, times the apothem. So 609.4 times, what is the apothem? Here, okay. Okay, we got it right here, 304. And what am I missing?
Divide by 2.
Divide by 2. Good. Okay, and what do we get for 609.4 times 304?
585,257.
Big number. Very, very big number. Yeah, so 185,257.6. Yeah, so divide that by 2.
92,628.8.
Yes, 92,628.8 inches squared. Very large area here. Very big shape. So that's our area, and that is our perimeter, and that is really our lesson today, guys. So I am almost done making your exit ticket. As I work on this, I'll leave this up. If any of you have questions, please feel free to ask. But if you give me just a minute here, I will have your exit ticket ready in about maybe 5 minutes at most, because I'm going to want to make copies of it too. Give me just a second. So here is the sneak peek of the exit ticket, and then I'll make copies. You have 2 questions where you're going to state the most specific name for each polygon. That's what we did during the first half of class. And then the last question shows a polygon, a regular polygon, and you're going to find the perimeter and the area. So I will be right back with copies, but that is all for today.